Welcome back to my YouTube channel. My name is Fernando, and today I'm going to do something a little bit new. In the past, I've solved katas and posted solutions right away going into code. But as you get more complex problems, going into code is really not feasible anymore. So you have to really understand the data structures and the algorithm that you need before you go into the code. And so I'll be wanting to do a little bit of upskilling. So I'm probably going to be doing a bunch of Codewars and lead codes, lead code problems, and eventually try to get into a good tech job. I know the market is crazy right now with AI, but skills are skills, right? So I'm hoping that skills still matter in the end. And this problem in particular is a 4 Q. Not really sure how you say that, but it's a rank 4. And the name of it is determining if a graph has a solution. I'll put the link in the description for you guys if you want to give it a try. I solved this in Python yesterday. And the way I did this is by, I had my Claude session and I told Claude, hey, do not give me any code. Do not give me a solution. Only when I need a little bit of code syntax, I'll let you know. I'll ask specifically for that. I also told it to be, stop making long-winded answers. Sometimes you ask for something and it explains this 2-page book, right? And it's not really helpful when you're trying to learn something. But I'll put those instructions in, I don't know, I'll try to put somewhere in GitHub somewhere that you can kind of see what it is. And yeah, so let's get started. Let me show you, I have the problem here and I also have my iPad. And I have a few arcs here that I wrote down prior to starting the video, and we are going to be trying to understand the problem. And basically I solved it yesterday. I was pretty good understanding the logic behind the algorithm and how to get to the solution. I was a little bit iffy on the code implementation, which is normal when you're starting to do this type of problems. And after I was done, I was like, okay, let me do this tomorrow to see how much memory recollection I can do and to see if I can come up with this solution again and the code all on my own. So first of all, let's read this problem. This is a graph problem, and basically they give us 3 arguments. Start, which is the initial node of the directed graph. Pay attention, directed graph. The end is the destination node. And they also give us arcs, which is a list of tuples, which has a source and a target. So if you look down here, we have a bunch of tuples, and then this would be your source, and this would be your target or destination, whichever you want to call it. In this case, we have only 2. Oh, we'll draw this a little bit later, but let's go back to finish reading the problem. And they want us to return a Boolean, depending on whether the destination node can be reached from the initial node by traversing 0 or more directed edges. That means that if the start and end nodes are identical, then the end is trivially considered to be reachable. So basically, they're telling us if we want to reach A to A, even if you don't trouble at all, that is reachable, right? And then also if the start and end node are distant and either node does not appear in arcs, then you should return false, since there is no sequence of direct edges that you may traverse to reach the end from the start node. You will not assume any properties of the all right. Also give us a link to adjacency list, and you can read that on your own, but it's a Wikipedia link. Okay, so let me switch to my iPad. let's take a look at these arcs and just understand how they will look visually. Okay, so here we have A and B. So we have A and B. Remember, it's directed, so we have to go. We can only go one direction, and then we have A to A, which basically A goes to A. So it will look something like this, and that is the visual representation of those two values in the arcs. Now let me see if I can remember from memory recollection how, or basically anything that I remember from yesterday. So I'm gonna do some pull some of those memories from yesterday to see if I can remember the whole algorithm. It's gonna be hard, but we'll see if we can do it. So the very first couple of things that I remember is that we need a queue. Yesterday I solved this problem with BFS, which is breadth first search. And excuse my writing, I write terrible. And so some of the data structures that I remember what we need are queue. Probably the most important one is queue for this algorithm. We also need a set, and we also have a dictionary and a list. Now, these two are very common to use in programs. By the way, I'm using Python, if you hadn't realized from the beginning of the video. And these two are also very important, but a little bit less used. Maybe queue is less used than set, but nevertheless, they are very important data structures. And so set is actually used to keep track of all the scene nodes. So you don't have duplicates. Set will only keep one value. So if you try to append one to it, or if you're trying to add one to it and one is already there, you won't be able to do that. So it's unique values in the set. And dictionary, basically you have a key value pairs. And the list is just an array in most of the languages, so that's very common. Now the queue, without looking it up online, I don't use queues that much, like in my day-to-day programming at work. I'm an IoT developer, so I deal with a lot of data, real-time data, and simulations. But queue is something that I don't use very often. But let's see if I remember correctly. That queue was it FIFO? First in, first out? And this is a little bit fuzzy right now. Let's test that theory. So let's say that we have A and B. We call Q at, we'll throw A. So now the set has A. I'm sorry, now the Q has A. And then we do Q at B. Will that be BA? Will that give us B? Yeah, the Q, I'm not entirely sure if I remember the way the data structure worked. We'll put a pin on that. Let's just say this is a little bit fussy right now. Let's mark that with red. And now let's talk a little bit about what I remember for the algorithm. So for the algorithm, I remember that we initialize the queue. So we'll initialize a queue, and I'll just name this a queue just so to keep this short. And so we initialize that, and then we also initialize our scene set. And then we also need to initialize our neighbors. And by that, I created a function called find neighbors. We'll just call it find n for now, and which will have to feed the arcs. And I believe that was all the initialization before going into the loop. But before we jump into code, let's try to see if I can remember the algorithm. So the algorithm was, we initialize a queue, we dequeue. Is that how you spell dequeue? Maybe we'll just put dequeue. We dequeue the queue. Let's just write queue. So we dequeue the DQRQ. It's getting complex to say that. And then because we dequeue that value, we'll also mark it as seen. This is getting really, really hard to remember. The next thing would be to do something with the neighbors. Wow. I'm having hard time understanding, remembering what was before, after this. So it was the dequeue. So like, let's just, for example, if we have, and then, so for example, the DQ will be A. Okay, I'm remembering a little bit. I believe I had another variable, which was, actually, I don't know if it was a variable current. Let's just say current for now, and yeah, current. And so we'll have DQ, so, and then mark that as current, and then also mark that as mark seen. I remember doing something with the neighbor, so let's just say we're doing something with the neighbors here, but honestly, I don't remember. So the memory is very, very fuzzy. So what I'm going to do is I'm going to go, and this is the session from yesterday. So I'm going to say working on don't need give me some arcs. And I just want a few arcs so that All right, so we have an arc. So let's write that down. And then B and B. Okay, so the first thing we want to do is let's just go ahead and do the neighbors. So let's just call it N. It's going to be a dictionary, and then A is going to have an array of destinations. So in this case, B, which is this one. So this is our first destination. And then A also travels to C. Now C travels to A, and B travels, B travels to B, but I don't remember if this. Okay, let's just add it. Okay, so the start's going to be A. The queue, we're going to start with start, which is A. Scene, we're going to say also start. This is a set. Let's actually see how let's just see how a queue works, because I think that's holding me back. Okay, so it was a FIFO. First in, first out. All right, so I think I have it right. People join at the back. The person served is always at the front. First one in is the first one out. Let's see how. Okay, so that's very useful. So let's make a queue. Okay, so that's very useful. Let's make a queue. Let's make a queue cheat sheet. So if we have A, B, and C, this is going to be our front. This is going to be our back. Then they go out from the front and in from the back. And then in Python, DQ will So whenever we're taking one out from here, that will be a DQ. And we are putting one in, will be NQ, right? Yeah. You see what I mean? How AI give you extra information that you're not asking for. See, like I'm only talking about Qs, but then it added this scene thing, right? That we didn't ask for. And before, you ask about the adjacencies list, like, and it has some specific instructions not to add things that I don't ask for, but still do it. And actually, I'm not even sharing my screen. You see here at the end how it's talking about the set, like we didn't ask for anything about that, right? We just asked about the queue. And over here, it just asks about if you want to do the agencies list, and we don't. Anyways, I always think it's really funny how it gives too much information. Sometimes it makes things a little bit confusing. Okay, so now we have a little better understanding how the queue works. So hopefully that helped us. So the first thing we need to do is dequeue the queue. So we'll get, and that's going to be our current. I don't want to remember what current did for us, but current will be A, and we'll also mark it as scene. Now we need to find the neighbors. So we'll get the neighbors of A. In this case, we get B and C. So I believe we get, so get the neighbors. Get the neighbors of A. In this case, we get B first. And I want to say we NQ QB and mark as seen. Then we have C, we NQ and also mark as seen. I'm very iffy about this portion of the algorithm. But let's see what so let's just see if, let's just keep going. I hate not being able to remember. I think part of the problem is that I can't visualize what we need to solve, how we need to solve using the queue. Usually I'm a very visual person, and actually NQ B and C sounds like it could be good. So then after that, we had this last step. The middle step was very hard to remember. And the last step is also very hard to remember. But let's see if I remember a little bit from the code. I think we had to do something with the queue here at the end. So at the end of this, the queue is, let's just write the queue here. The queue should be looking something like this. We started with B, and then we put in C, remember, at the back. So our queue should look like this. But I remember being three-step algorithm. DQ, run through the neighbors, and then the last step is very, very fussy. So I'm going to have to ask Claude for that. So only give me a direct answer, no other info, no other unrelated info. Remember, and let's just make sure that we have this. And the first step, second step, let's see if we get good information here. And I believe that was just checking if the key existed. Let's see, if the guard is about the neighbor you're about to enqueue, what step will make you skip it instead of queue? Skip it. Let's see. Okay, so the guard is the neighbor already seen. If yes, skip it. Oh, okay, so if it's already seen, skip it. So here we'll skip if seen already. And now let's just see how close I am to the results by taking a screenshot. And I wasn't showing my computer. I really need to get better at that. I need one of those switcheroo things where you can switch the screens really quick. But anyways, I had pasted a picture here and just to see how close we were. And this we can ignore because I've already had that on my skip here note. Mentally, I was like, yeah, I need to check that before I do the thing inside the loop. But Claude thinks that I didn't do that right. And then missing the other wrap, we need to just do a while loop. And what we have, while the queue has values. So while the queue has values, we do all these things, and I think that's the algorithm in a nutshell. It seems complicated and it's kind of hard to understand when I'm not too familiar with queues. Let me take a screenshot. I think it's pretty close to my screenshot, but I'll just take a screenshot again. And then we can go ahead into, so I have the screenshot here, which we can, I'll put it to the side of the screen. And then let's go ahead and train for this kata again. Now I'm a little scared because, like I said, I just did it yesterday. But we'll see if we can remember most of it. All right, so the first thing I remember I did was to create the function to find the neighbors. So I'll just call it find in, and we'll just pass the arcs. Now we want to be we want to have a return type here. So it will be a dictionary, and this will be a dictionary of string. It says string, and this will be a list of string. And I'm hoping that is good. I'm hoping that is correct. But either way, we'll get an error if it's not. Basically, we want to return a dictionary that looks like this. It has an array for each key. And so if you return anything other than that, you should get an error, a type error. So let's just call this neighbors. It's going to be, there is a default function. And default, was it default something? Yeah, default dictionary. And let's see. All right, so from collections import default. So I've had all that right, and then these here. And now we have a default dictionary. And I believe that's it. Now we can just I don't remember. Okay, let's just see if it works. So we'll do and let's see how that looks like. I think this is just Q. Is it just Q? Okay, we'll figure that out a little bit later. let's actually print the tuples just so we can compare. All right, so A, B, we have our dictionary, A, and this is our target, our destination. Or I should say the next node. And then we have A and B, similar one. Yeah, we have here a little bit longer one. A and B. So A and B, then we have B, C, yes. Now take a look at C. C has 3 nodes attached to it. B, D, and A. And then we have B, D, and A. So it looks like we are building the adjacency list. I don't even know if I'm saying that correctly. Well, we're building that list correctly, as you can see here by the results. So let's get rid of this and this. So we have found the neighbors. Now the next thing will be to, let's make sure that I can, obviously, I think, okay, DQ, okay, let's just DQ. Let's just run and make sure that that's the correct. All right. So here we'll just call it and we're going to put start in it, and then we're also going to say scene. Scene is a set. I don't remember if we set start like this. So let's just copy this for our sort of information here in the future. And let's ask how so just weird. I thought that was for dictionary. It looks like just like this. So now we have the start, and I believe now we can have our while loop, while Q. So while Q has values, we're going to be in this while loop. Here we're going to do a bunch of things, but here at the end, we are going to return a Boolean if n is in scene. I believe, is it n in scene or I don't know. Well, let's just run it to see what happens. If I think it's just n in scene. Oh, yeah, wait, is the loop? Okay, so it still runs. So that's a correct syntax. So this is going to give us a Boolean if the n is in the set. So that's going to be true or false. And that's eventually what we want. Now, the meats and potatoes here is going to be oh wow. Mac Windows go crazy sometimes. So we are here. We need to my memory is so fuzzy from this. In this, that was just yesterday. So while Q, I feel like I forgot everything already. But based on our initial algorithm on paper, so current should be Q pop left. That should give us A. And then we need to iterate the neighbors. So this should be neighbors get set current. Let's look chicken claw to see. That was not that one, so get. Okay, neighbors get current. Okay, so I just need for neighbors get. Basically, this will give us the array for the current. But if there's no key for that specific node, then it will just feed an empty. So basically the list will just go to the next neighbor. The loop will go to the next neighbor, I'm sorry. So now we'll see if the specific let's see if n is not in scene, then we can say, remember, I'm not looking at my algorithm on paper. Like, I'm not trying to cheat or anything. On my other screen, I have my OBS controls. That's all. So I just put these on the side just so I can reference. But if you want to take a screenshot of that or take a picture, and then you can have it as well. I just can't leave it here, or can I? Pin to screen. Oh, that's useful. That is useful. Wow. Learning new things every day. Okay, so basically I'll look at my drawing or my writings, and I'm trying to figure out how to write the code. So if n is not in scene, then we should call Q append. Is it append? Yeah, append. And that's going to be n. We're also going to call scene add n. And let's just see how that does. It's probably going to fail. Oh, it didn't. Okay. And let's go ahead and do an attempt. And the attempt did fail. And so to avoid making this super long, let me look at my past solutions. So it only showed me one. I thought I had like 3 solutions. Okay, I'm looking at this and it looks identical, so I'm not sure what's happening. Let's see, neighbors is the same, right? I wrote the function str neighbors append. Okay, the find neighbors function looks pretty much identical. And then self graph neighbors, we initialize Q and scene. Okay. Oh. So Q needs to be like that. That was my other error. So I'm going to mark this here. Okay, that was the entire error. So I'm going to take a screenshot of that. And I'll save that for my future reference to investigate why just that one change made a huge difference. No, actually, let's just do it right now. Let's just ask Claude, right? That's what we have, a great AI today. My submission failed because I was missing my brackets. let's see, DQ takes an iterable and adds each element to the queue. DQ start iterates the list A. One element A goes in. DQ start iterates the string. Oh, so if we don't have the brackets, we're basically building a string, which is not what we want in our problem. Got it. That makes complete sense. Okay. And I'm just going to submit this. And I'm going to see if my past solutions are in here. Because I had... Let's see. Oh, that's crazy. It only show... It doesn't save the previous ones. That's weird. I had like 2 or 3 solutions. I mean, the very first one was terrible. So... I need to somehow keep track of my solutions, maybe on a GitHub repo or somehow, because that way you can compare how you start and begin, how you start and how you get to the last iteration of your solution, which is always a little bit better than the first one. So yeah, guys, this is the end of this video. I hope this was useful and you can treat this as a sort of learning experience. I'm telling you, in the middle of this, I was having terrible brain freeze when I couldn't remember some of the things that I learned yesterday, but at the same time, this is good for you. Like you have to struggle in order to learn. Like that's the only way to learn. You have to struggle. You just can't use AI to give you all the answers, because then you're not going to learn anything. And so yeah, so for most of this code, I remember all of these. I remember how to find the neighbors. I roughly remember most of these, but the loop itself was a little bit fussy. But basically we're trying to make sure that we get to a point where whatever we write down in pen and paper, it's a good blueprint for us to come and write in code. Now, eventually, now I'm actually just starting to do this sort of complex problems. And this is probably not a complex problem for a lot of advanced programmers and people that do these things a lot of time, like every other day. But I don't sit here and do these little challenges. So I'm once I do a bunch of BFS, which is the algorithm that we did today, breadth first search. Once you do a bunch of BFS and graph problems, then this is going to be like a second nature. And that's what we're trying to reach eventually. And yeah, I've talked a lot today. So let me know if you find these tutorials useful. You see me struggling. I legit thought about stopping the video like halfway because I was so aggravated with me not remembering, and it just feels like weird, like I'm making myself feel really dumb, if you want to say that. But I know it's just practice, and I wanted to share my experience as I learn more and more about these problems. And yeah, just let me know what you think in the comments. If you want to see lead code, I plan on doing lead code, and I'm planning on doing, actually, let me give you a sneak peek since you stay till the end. So I'm working on this is a byte coded, right? I'm not going to lie. This is straight byte coded. It's the backend is in Golang and the front end is React. Basically, it's using Flossy, and Flossy is, it can sort of duplicate AWS locally. And so my goal for future videos is to build big systems, scalable systems, or break them to see what's happening. So for example, here I have a load balancer, 2 backends. I can kill one backend. This backend now is killed. Now I can send my request to the load balancer, and they're all going to go to the one that is still up. I can restart that, and now the load balancer is doing its job. And so in the future, I want to do problems like how to solve a URL shortener, or how to do YouTube videos at the scale, etc. And even other things that are pretty cool to do at scale. Thanks for watching, and I'll see you on the next one.